Hello everyone. In this video, we will work with higher derivatives and we will go up to second derivatives in this lesson. The notation for the higher derivative is depends on the number of prime that you have here and also the square, the number of the exponent. So for first derivative, you have y prime, or you can write dy as a function of x, okay, and f prime of x or dy over dx. For the second derivative, then you can see that you have a double prime here. You have a square as the exponent for this capital D. So it's the second derivative of y as a function of x. Or you can have f double prime of x. Or you can write dy squared over dx squared. This notation is popular and it will be used throughout the entire lesson. Most of the questions, they won't ask us simply as please find the second derivative of this function. It will just say given y equal to square root of 1 minus 7x, and then we have to determine d squared y over dx squared. So this notation representing that you have to find the second derivative of this function. Second derivative has quite a lot of applications in mathematics. So we will get into application in the next videos or so. I can tell you one application of the second derivative is to calculate the acceleration of your car. The first derivative is to find the speed of your car. The second derivative is to find how fast your car is moving, so in plus second, so which is your accelerations. Alright, okay, so let's get started with the mathematics first, and then I think we will get into the application later on in more videos. Alright, so before we can get to the second derivative, I have to find the first derivative first. Okay, so I will write y equal to 1 minus 7x, all of it to the exponent half. Because I haven't differentiated yet, so we still have to write the y. I always remind everyone to be mindful of your notation. So what you write on your next line, or the way you present your answer for mathematics. Okay, so you have to present some logic with that as well. So this is your y. It's the exact same function that you have, but you convert to the exponent here. But the next line you write dy over dx, it means that you are going to differentiate. Don't just put an equal sign. Okay, so then it's not logical in terms of what the step that you are going to apply next. So this is dy over dx. That means I am going to apply the basic rule for differentiation. So I take the exponent, multiply with the coefficient that I have in front of this bracket. At the same time, I will take 1 away from the exponent. So a half minus 1 will be negative half. Don't forget we have a chain rule in this case, so we have to multiply by negative 7. Okay, then if simplified it, we have negative 7 over 2, 1 minus 7x, all of it raised to exponent negative half. And your next step is to find the second derivative. After you get the first derivative, you find the second derivative by writing this. Okay, d squared y over dx squared. So that means you can just continue differentiate this function right here. So I will take negative 7 over 2, and I multiply that with negative a half. And at the same time, I will take 1 away from this exponent. So this will be negative 3 over 2. And I also have to multiply by the derivative of inside this bracket here, apply the chain rule. So I should have a negative 7. Okay, so the next step is just to simplify your answer. To simplify your answer, I believe I should have the answer is negative 49 over 4. And then 1 minus 7x to the negative 3 over 2. But if I have to write this as positive exponent, so it will be negative 49 over 4 times 1 minus 7x. all of it raised to exponent 3 over 2. Okay, as my final answer. Okay, so this question is pretty simple. We just have to keep differentiating until we reach the level of the higher derivative that they want us to try. So in this case, we have to get to second derivative. And all we do is just apply the basic rule, and then we apply the chain rule, okay? Or derivative of a function raised to a power, and then it's involved the chain rule. So for the next question that I'm going to try is a bit more complicated. When you get to the second derivative, you have to apply the product rules, okay? So in this example, I said differentiate twice, or in the way that I asked you to find d squared y over dx squared, given y is equal to this function. Okay, so before we start with the next step, I would like everyone to analyze your functions. So your function has -4 divided by these radicals. So since you have a something divided by, do you need to use quotient rule? No, we don't. In this case, because your numerator is just a coefficient, so you can easily convert this into a product of -4 multiplied by this function. Then we go from there. Okay, so but then again, we have to remind ourselves that we need to convert to the correct exponent, or else we will have everything incorrect because of that wrong exponent. Okay, so this, if I raise that, then it will be -1/3. Okay, so it will be to the exponent -1/3. So let me rewrite this. Okay, so do step by step. I will write it as y equal to -4 over 1 minus 2x, all of it to the exponent 1/3. Okay, so this is 2x squared. And then my next step is to write this to the exponent of -1/3, as I have done earlier for everyone. Okay, so now y prime, or dy over dx. So I will take -4, I multiply this with -1/3, and then I will take 1 away from the exponent. So this will become -4/3. Okay, don't forget to multiply with the derivative of what inside the bracket here, the chain rule. So it will be -4x. Alright, so I multiply this -4x. So at this point, I strongly recommend everyone to simplify. Okay, simplify to the coefficient here. Okay, so dy over dx will be equal to -16 over 3x. And then I multiply this with 1 minus 2x squared, all of it raised to the exponent -4/3. Alright, so double check our work first. So that and that, which is correct. Now, you see that you are having a x in this term as well. So you have -16 over 3x, you multiply by 1 minus 2x squared, all of it raised to the exponent -4/3. So to differentiate one more time, you have to apply the product rule. Okay, so in this case, the product rule. So it's u and v. Okay, so then product rule to find the second derivative. Okay, so I need to make sure that I write it down to remind everyone. So you need to apply the product rule in this case. So to apply the product rule, then I'm going to let u equal to -16 over 3x. Okay, so what do I have as du over dx will be -16 over 3. Okay, it's just the coefficient in front of x. So I will let v equal to 1 minus 2x squared, all of it raised to the exponent -4/3. Then dv over dx will be equal to a -4/3 multiplied by 1 minus 2x squared. Okay, negative 4/3 minus 1 will give me negative 7/3. And then I multiply by negative 4x. Okay, as a chain rule. Then dv over dx will be equal to, simplify this, I should have 16x over 3 as positive. And then I multiply this with 1 minus 2x squared to the negative 7/3. Okay, so we don't need to try to write this as any kind of positive exponent, because what you need to do is you need to still fit it into the formulas of d squared y over dx squared. Okay, so then my next step is writing d squared y over dx squared. I remind everyone again, okay, be mindful of the logical writing of your mathematics. So from here, your dy over dx, now you differentiate twice, so I need you to write dy squared over dx squared, because now you're going to apply the product rule into this line. Okay, so what does product rule say? Product rule say u dv over dx plus v du over dx. Okay, so we are going to remind ourselves of this rule. So u is negative 16 over 3x. Okay, so multiply that with the derivative of u. V is a function of x, so 16 over 3x. And this time I have to multiply by 1 minus 2x squared, all of it raised to exponent negative 7/3. And my next step would be v, so it will be 1 minus 2x squared, this raised to the exponent negative 4/3, and then I multiply by du over dx, in this case negative 16/3. Okay, so we have found our u du over dx, and then v and dv over dx. So let's double check that. Okay, so this is u, which is correct. Okay, and then I multiply that with dv over dx, that means 16 over 3 times x, multiplied by 1 minus 2x squared to the negative 7/3. So this is my dv over dx. Okay, so it's good. And the next step is to write v. So here's my v to the negative 4/3. And this one is my du over dx, which is just equal to negative 16/3. Okay, so the next step is to factor. Okay, we factor, and then we will find the common factors between this two sum. So this product here will have common factor with this product. Okay, so in previous video I show everyone how to recognize the common factor and what to pull out of your bracket. Okay, so first of all, why don't we take a look at the 16/3? So I have the 16/3 here. I have this as 1/16/3 as a product, and here is 1/16/3 as a product, as a negative as well. So I should pull out negative 16/3. Okay, now the next one I should look at is this one. This one. Okay, so this one that I highlight in purple here. Okay, so this will be your next common factor. 1 minus 2x squared. And I would like everyone to note for yourself that, so what type of exponent that I bring this to be here? So you have negative 7/3 and negative 4/3. The lower number should be negative 7/3. So you always pull out the one with the lower exponent. So what you have inside the bracket is you left with 16/3x squared. Okay, you already pulled the negative 7/3 exponent of 1 minus 2x squared outside of the bracket, so you don't have any left. And your next fraction will be negative 7 over 3 divide into this expression. Okay, so let me write it down for everyone before we are going to get a bit confused because of that. So 1 minus 2x squared, all of it to the negative 4/3, right? So 1 minus 2x squared, all of it to the negative 7 over 3. So this will be minus 2x squared of negative 4/3. Add that with the 7 over 3. Okay, so as you subtract negatives of 7 over 3, so you add 7 over 3. So in this case, 1 minus 2x squared to the exponent 1, right? So negative 4 over 3 plus 7 over 3 will be 1. So negative 4 over 3 plus 7 over 3, the answer is 1. So inside this bracket, what you have left is just 1 minus 2x squared to the exponent 1. Okay, so let's put this in this cloud, because I just want to remind everyone how I come up with 1 minus 2x squared. Okay, d squared y over dx squared. So I have negative 16 over 3, and I multiply this with 1 minus 2x squared, all of it raised to the exponent negative 7 over 3. And inside the brackets, I would like to take a common denominator. Okay, so I want to take common denominator of what inside this bracket. So to take common denominator of what inside the bracket, I will have to multiply this binomial by 3. So I will write it down for everyone here. So 16x squared plus 3 times 1 minus 2x squared. The whole thing divided by 3, because I want to take common denominator of what inside the bracket. Okay. So the next step is to expand or distribute the term. So d squared y over dx squared equal to, okay, dx squared. So this will be negative 16 over 3. I'm sorry, I think my pen is kind of acting up, but I'm about to finish this lesson. So inside the bracket, I should have, okay, I will write it like this, okay, 1/3 multiplied by 16x squared, okay, plus 3 minus 6x squared. Okay, I write it like this because I want to pull the half, I mean the negative 1 over 3 outside the bracket. Then I should have negative 16 over 9. Okay, just a reminder to everyone that I take this and I multiply this. Then I end up with that number. And then I will have 1 minus 2x squared. Now you see that I just want to have just I don't want any denominator inside the bracket, so I bring them all out and multiply. I take 1/3, I multiply negative 16 over 3, I get negative 16 over 9. Okay, simplify what I have in this bracket. I should have 10x squared plus 3. Okay, so this is the exponent negative 7 over 3. I don't want to forget that. Okay, so now I am going to write it as positive exponent. It means I will write negative 16 multiplied by 10x squared plus 3. 9 still remain as the denominator, but I will bring my 1 minus 2x squared to the denominators, and I will change this to a positive exponent of 7 over 3. All right, so let me rewrite the number 7 to make sure that everyone understand that I make that into a positive exponent 7/3. Okay, so I think we are good. All right, so let's go back and review what we have. So in this lesson, basically what I'm asking everyone to try is to differentiate twice. Okay, so to differentiate twice. So when you differentiate twice, you will have to make sure that you apply the correct rule for the derivative as well. So for this particular question, you raise to an exponent, and then you apply the chain rule with that. You have the first derivative as this, and then you take a look at the first derivative. You don't have to apply any product rule. All you do is just apply the chain rule, derivative of a function raised to a power, take derivative of that function, and then multiply by the derivative of what inside the bracket, and then simplify your answer. Write it as positive as required. Okay, so this example is pretty simple, but higher derivative can get complicated because after you take the first derivative, you end up with a product rule or even a quotient rule to work with. Okay, so in this case, for this question, after you found the first derivative, here is our first derivative, right? Okay, that's the first derivative. So what I have to do is I am going to analyze my result, and I see that I have the product here. So negative 16/3x, a product of two functions. So then I have to identify u and v, and then apply another derivative to this. Then I have to use a product rule. Using product rule, we have to identify u and then v, and then take derivative of each function. Take derivative of each function, and then try to write it in the form that is easier for us to recognize and easier for us to simplify our answer or pull out the common factor. So then again, I keep repeating myself how to show you how to take out common factor in this case. So I hope you remember that. Okay, if you don't remember the steps, then go back to the previous video because I went over the detailed step or the behind the scene of our common factor. You basically divide your common factor into your terms. Okay, so in this case, it turned out that 1 minus 2x squared raised to exponent 1 in this case, and then the rest of them we just simplify with the using the algebra. Okay, thank you everyone.